Hello everyone. This is a video on section 8.5 part 1 titled Dividing Radical Expressions or Dividing Roots. In this video I'm going to be going over a version of the section 8.5 part 1 Knewton Alta assignment. Now please understand that the version and the questions I'm going to be seeing in this video may or may not be the same questions you see when you do the assignment on your own. But the objectives will be the same. The types of questions you see will be very similar. So I'm hoping that watching me go through these here will help you in some way when you do it yourself. Alright, so here's the assignment page. Now you will not be seeing the words preview of, you'll just see the title of the assignment. And in the upper right corner you have your mastery bar, telling you how far along you've gotten. Then the objectives, which in this particular assignment there is only one objective. That is simply divide radical expressions, right? Divide and simplify. And you've already seen pretty much how to do this in an earlier video. If you've been watching the videos I've been putting out, I have gone over an objective in a previous video on using the quotient law or quotient property to help simplify radicals. I'm going to be doing the same thing here. And then every question you see should have a feedback button on the bottom, right, so you can send feedback to Knewton. Should also have a more instruction button. Right, you won't see the instructor sheet button, that won't be there. But you should see a more instruction button. You can click on this and you'll be provided with extra reading material, extra videos to help you out with whatever objective you're working on. Alright, so in this first question, as with all the questions, we're going to be dividing radical expressions. So here I'm dividing two radical expressions with a single term. We have the cube root of 243u to the 10th divided by the cube root of 3u squared. Alright, and as I said, we're going to be making use of that quotient property, which I'll really quickly recap here in a minute. Alright, so if you recall the quotient property or quotient law for radicals, here I have a cube root divided by another cube root. So we can put this together, make it the cube root, and then the radicand of this new cube root is just the ratio, the quotient of the previous radicands. So it's the cube root of 243 u to the 10th over 3u squared. And then I'll actually simplify, divide and simplify the fraction, and then we'll simplify the radical. Now 243 divided by 3 is 81. And u squared, u to the 10th over u squared, the two u's would cancel from the denominator, and cancel two u's from the numerator, be left with u to the 8th. Alright, and then now I try to simplify this radical. Alright, now it's a cube root. I'm going to use the product property now to break it up to a cube root of perfect cubes multiplied by a cube root of non-cubes. Now 81 is 3 to the 4th power. It's 3 to the 4th power, not 3 to the 3rd. But I could pull off 3 to the 3rd, which is 27. Alright, 27 times 3 is 81. I put 27 in one radical, 3 in the other. It's 81. Then u to the 8th is not a perfect cube. Right? 8 is not a multiple of 3, but 6 is. Right? 6 is the largest number that's a multiple of 3 that's less than 8. So I can break up u to the 8th to u to the 6th times u squared. So this cube root of 81 u to the 8th is equivalent to the cube root of 27 u to the 6th times the cube root of 3u squared. And the cube root of 27 is 3, right? 3 to the third power is 27. Cube root of u to the sixth would be u squared, right? U squared to the third would be u to the sixth. So that's 3u squared on the outside times, and then the cube root of, and then you know 3u squared on the inside of this radical as well. And there you go. There's as simple as that radical's getting. Right? 3u squared times the cube root of 3u squared. And if you'd like to test it out, replace the variable u with any number but 0, right? Because you can't have a denominator of 0. Replace u with any number but 0 and see if the value of the original expression is the same as this value of the expression we got at the end here, and it should be. And I leave it to you to test that out. Replace u with different values and check it out. Alright, but this is what I'm going to enter. Alright, so we had 3u squared times the square root, nope, not square root, cube root, my apologies, cube root of 3u squared. Make sure that last 3u squared is all underneath the cube root symbol, and this should be good. And after every question, whether you get it right or wrong, there should be an answer explanation. Please read through this. Either way, you know, if you got it right, read through it to make sure you got it right for the right reasons, that you didn't just get lucky. Or maybe they're doing it in a way that's alternate to what you're doing, and maybe the way they do it you like better, and you can do that for future questions. Now, if you got it wrong, you know, definitely read the answer explanations. Try to figure out where you went wrong, why you got things wrong, and then hopefully you can learn from your mistakes and fix things in the future. Okay. So next question, same objective, right? Same objective, divide radical expressions, and it's going to work the same way. Right? Now notice these are both square roots. These are both square roots. So notice at the end here, they're saying assume n is positive. Now the reason they're doing that, they should also say assume m is positive as well, so that way we can actually use the quotient rule. Because remember, the quotient property and the product properties for radicals can only be used when you're dealing with real numbers, and even roots of negative numbers are not real. So they should have also stated to assume that m was positive. But either way, let's just assume the variables are positive, and this way, at the end of the problem, you know, you don't have to worry about using absolute value symbols. That's really the only reason they're doing this here, is so that at the end you don't have to worry about absolute value symbols, you know, when you're simplifying even roots, square roots, fourth roots, sixth roots, etc. Alright, so I'll write this out and we'll work on this on some paper. Alright, so once again, square root divided by square root like this, I can use the quotient property and put these together. 63, you know, let's make it the square root of a fraction, where the numerator is this 63mn, the denominator is 252mn cubed. Let's simplify this fraction here. Now you can see the factors of m cancel. One of the n's cancels, leaving me with n squared in the denominator. And 63 actually goes into 252 4 times. Alright, so this is the square root of 1. There'll still be a 1 in the numerator, even though everything cancels. There's still a factor of 1. 1 over, and then 4n squared. That's all that's left in the denominator. And then we can reapply the quotient rule going the other way. You know, the square root of 1 is 1 in the numerator. And then the square root of 4n squared would be 2n. Again, technically it should be 2 times the absolute value of n, but they asked us to assume n is positive here, right? Assume n is greater than 0, so that way we don't need the absolute value symbols. Right? So all I'm going to write here is 1 over 2n. And that's it. Very simple application of that quotient rule. So 1 divided by 2n. Pardon me. I'm so sorry. Okay. Next question. Same thing. So do it again and again. Notice they're having us assume that both the variables are positive again. Right? Once again, it's just so we don't have to worry about using absolute value symbols after simplifying even roots, which we have here. We have square roots. Okay, so let's write this out and do it on some paper. Alright. So we're going to make this the square root of the fraction with these two radicands. I'll just do the cancellation right now. Now 12 and 43 have a common factor of 3. Divide both of these by 3. 12 divided by 3 is 4. You'd have 4 left over. 243 divided by 3 is 81. P squared over p to the 6th, you'd have p to the 4th left over in the denominator. And then q to the 5th over q to the 3rd, you'd have q squared left over in the numerator. Right. And then reapplying the quotient rule here, the square root of 4q squared would be 2 times q. And once again, technically it should be 2 times the absolute value of q. Right, the square root of q squared is the absolute value of q, but once again they told us, assume that q is positive, so that way we don't need to put absolute value symbols. And the denominator, square root of 81 is 9. Square root of p to the 4th would be p squared. And you really don't need p to be positive here, because p squared is always non-negative, but again, they just told us assume that the values of p and q are positive, so that way I don't have to worry about absolute value symbols. And then that fraction is as simplified as it gets, right? So I have 2q in the numerator and 9p squared in the denominator. So 2q in the numerator, 9p squared in the denominator. And that should be good. Okay, next question. And I believe this will be the last one. And we're doing the same thing. Right. Once again, even roots, square roots, so notice they're making it easy on us, telling us, hey, assume that the values of the variables are positive, so that way you don't have to worry about using absolute value symbols or anything like that, or can I even apply the quotient property or the product property or whatever. Alright. Okay, so once again I got a square root divided by a square root, and because first of all, u and v are all raised to even powers, so really wouldn't even matter that u and v were positive as long as u and v weren't 0, because you don't want to divide by 0, have a denominator of 0 anywhere. Anyway, they're telling us that u and v are positive, so I can apply, these will be real numbers, and I can apply that quotient property. And once again, I'll just do the simplification right now. Now 294 and 600 are both multiples of 6. Now you can do the whole factor tree stuff. I'm just telling you right now, this is 6 times 49, and this is 6 times 100. Right, so 294 over 600 would reduce to 49 hundredths. And u to the 4th over u to the 4th, no more u's. And then v to the 6th over v to the 4th, you'd be left with v squared in the numerator. So this fraction here simplifies to 49v squared over 100. And then doing the quotient property again, the square root of 49v squared would be 7 times the absolute value of v, But one more time, v is assumed to be positive, so I don't need the absolute value symbols, right? So I'll just be 7v in the numerator, and the square root of 100 is 10 in the denominator. So we end up with 7v divided by 10. And let's check that, right? Let's punch that in. So 7v in the numerator, 10 in the denominator, and that should be good. Wonderful, and please read through your answer explanations. Alright, and that should be it for this version of this assignment. As I said at the top of the video, right, the questions I saw here, this version, are not going to be necessarily the same questions you'll see when you work on it on your own. But the objective's the same, the types of questions are similar, how you would work on them would be similar. So I'm hoping that watching me go over these 4 questions here helps you out in some way when you're working on the assignment on your own. And thank you very much for watching.